is a powerful program in its own right, but over time applications have been written to extend it, and they come in the form of add-ins. So in order to get the solver add-in activated, you click on File, Options, Add-ins. Notice there are no active application add-ins. Select Solver, go, check the box, OK. And notice we now have an analysis group under the Data tab with Solver. Now Solver, as the tooltip indicates, is a what-if analysis tool that finds the optimal value of a target cell by changing values in other cells used to calculate that target cell. So for us, we still have our budget of $300 per month. That's the maximum car payment we can afford. And when we used GoalSeek, we could tell GoalSeek to get to that $300 payment by changing the cost of the car. Or perhaps we might have told GoalSeek to change the amount of the down payment. Or perhaps the APR, etc. But with Solver, we can actually tell it to use all 4 of these parameters and change them at will to find the optimal solution to get us to the $300 payment. So let's go through this. Solver. We open up the dialog box. I'll say reset all so that you can see the process. Now, in using Solver, we're going to set an objective. Our objective is B12 because that's the car payment, the monthly payment. And we want to force that value to be $300, just like we did with GoalSeek. But we want to do it by changing variable cells. And unlike GoalSeek, we're going to pick a range of cells. We're going to say these 4 cells, the cost of the car, the down payment, the annual percentage rate, and the loan terms are all available to the solver to mess with, to change until it can find its optimal solution. So I'm going to go ahead and say solve. And notice that it's come up with a solution here, $300. But it changed the cost of the car, the down payment, the APR, and the loan term. And notice the number of payment periods, it's not an integer, and neither is the loan term. So in the real world, banks give out 3-year loans, or 4-year loans, 5 or 6-year loans. And so I want to get a little more sophisticated, and I want to put some constraints in to tell the solver, hey, you can look for the optimal solution, but you do have to obey or follow some constraints. So I'm going to say restore the original values. That will restore our sheet. But I'm also going to say report back the answer. So while I set all these cells back to where they were, so we can try this exercise again, I have a new sheet called the answer report that shows us how that first one worked out, what the original values were, and what the final values were. Okay, let's try Solver again. It remembers what we'd put in. Only this time, let's constrain the loan term to be an integer. So the way you do that is to say add and select B5 and say we want it to be an int. Say OK. And we also want to tell it to we want to tell the loan term, or the solver, to make sure that the loan term is less than or equal to the upper bound of 6 years. And we want to add another constraint to tell the solver that the loan term is greater than or equal to the lower bound of 3 years. And then I notice here that I was in the objective cell and accidentally changed it. So let me make sure that that's back to B12. Okay, that's our payment, and I just fat fingered it. Okay, so let's go ahead and solve this with our new constraints and see what we come up with. So it says solver found a solution, and we can see it here. Now we have an integer value for our loan term, which comports with what the banks allow. And we can see the cost of our car, the down payment of our car, and the APR that we need to talk to the bank and say, look, I know you were offering 4.5, but if you can give me 4.44, I'll give you a larger down payment of 5161.74, and then we have a deal. Okay, so I will keep the solver solution. I will select an answer report and say okay. And if we look at answer report 2, we can now see our original values and our final values. And that's how solver works.